Factor theorem. In previous lessons you've sketched curves like this, which is fx equals x cubed plus 2x squared minus 5x minus 6. And if we sketch that, you'll get a graph that looks something like the one on the right hand side here. And we know that it crosses the x-axis at minus 3, minus 1 and 2, and it crosses the fx or the y-axis in some cases at minus 6. But how do we know that minus 3 and minus 1 and 2 are indeed where our curve crosses the x-axis? Well, what should happen when they cross the x-axis? What should the f of x be equal to? It should be equal to 0. So in theory, if we substitute in each of our values for x into our original function, we should find that we come out with the value of 0. And we're going to have a quick check to see if that's the case. So if we put 2 in first, 2 cubed minus 2 times 2 squared minus 5 times 2 minus 6, well that should be equal to 0. Well, 2 cubed is 8, so that should be a plus not a minus. 2 squared is 4 times 2 is 8, 5 times 2 is 10, minus 6, which if you do that, you do indeed get the value of 0. So 2 is definitely one of the places where our curve crosses the x-axis, because the fx is equal to 0. Or in some cases it might be the y value is equal to 0. Now let's try the next one, which will go for minus 1. So minus 1 cubed plus 2 times minus 1 squared minus 5 times minus 1 minus 6. Well, minus 1 cubed is minus 1. Minus 1 squared times 2 is 2. Minus 5 times minus 1 becomes positive 5 minus 6, which is indeed again 0. And let's just hope that the final one, minus 3, also gives us 0. So minus 3, so minus 3 cubed plus 2 times minus 3 squared minus 5 times minus 3 minus 6. That's minus 27 plus 18 minus 5 times minus 3 is 15 minus 6, which if you work that all out, you do indeed again get that this is equal to 0. So we now know that every single time when we put in our values which cross the x-axis, we get the fx function is equal to 0. Now if I wanted to factorise the fx equals x cubed plus 2x squared minus 5x minus 6, we now know what our free value should be in our brackets if we were to factorise it fully. So our function, if we were to factorise it, should be the following. Remember, when you put them into brackets, it should be the opposite sign to what is shown on the graph. So where it crosses at 2 in the bracket will be x is minus 2. Where it crosses at 1 it will be x plus 1. And where it crosses, oh dear, and where it crosses at x is minus 3 should be a positive 3. Now the reason why it's the inverse sign is because remember when we put 2 into this one, we want to make that bracket equal to 0, because the only time you can get fx equal to 0 is if one of our brackets is equal to 0. So what the factor theorem is if we're told one of our factors that we think should work, so if we're told that x minus 2 is a factor of our original equation, which was x cubed plus 2x squared minus 5x minus 6, what we should get is we should get the value of 0 when we sub in 2, which we've already shown we do. So what is a typical exam question looking like for factor theorem? Well, it is simply like this. It says show using factor theorem that x minus 3 is a factor of fx equals x cubed minus 13x plus 12. So that means that we're expecting the value of 3 to work in our equation and make the function equal to 0. So 3 cubed, oops, let's rewrite that. 3 cubed minus 13 times 3 plus 12 will hopefully be equal to 0. That's 27 minus 39 plus 12, which if you do 12 add 27, that's 39, minus the 39 is 0. So remember, the key thing really to remember is that you want to try the opposite sign to whatever's there and just sub it into the function to see if it works. And then what you could be asked to do in the latter part of the question is you could be asked to fully factorise this original function, knowing that this is a factor. You could then use dividing by polynomials, which we've done in an earlier video, to show the fully factorised version of that.